3 and we're on unit number 4, and I'm a little bit afraid to tell you that we do one more unit of quadratics. This time we're going to spend a little bit more time with vertex form again, which tends to be our favorite. And so we're going to refresh a little bit today what they look like, what the key features are, and then we're going to do the algebra required to go back and forth between the different points. So we're going to start by graphing y equals x squared minus 6x plus 5. So my thought process is, first of all, is there anything that I know right off the bat that can kind of help me know whether I've got the right graph or not on my graphing calculator? Because they're not perfect. I know, first of all, that it has a normal step pattern and opens upwards. Upwards, okay, normal. It's as normal as they get. Okay. I also know from the 5 at the end that the y-intercept is 5. So I could write it as a point 0, 5. This is standard form, and it's not altogether helpful, but I have a sense that this thing has a minimum value because it opens upwards. And I have a y-intercept of 1, 2, 3, 4, 5. So I know that. So I'm going to type it into my graphing calculator and see what it looks like, and we'll try and model it onto this graph. Okay, so I made sure everything was cleared from the last time that I used it, and I want to enter my equation, so I need to be at y equals, and my equation was y equals x squared subtract 6x plus 5. So x squared subtract 6x plus 5. Okay. If my windows, which have defaulted to the normal settings, minus 10 to 10, negative 10 to 10, if I can't see it very well, then I might adjust my windows. But otherwise, I'm going to try to graph it and see if I can see it. Yes, not bad at all. So it looks like I have x-intercepts at 1 and 5-ish, not sure. And it kind of looks like I have a vertex at about 3, negative 1, 2, 3, 4, 3, negative 4, approximately. So I'm going to draw that onto my grid paper. So I didn't actually check any of those values on the graphing calculator, but approximately it looks like I have x-intercepts there, about there. And according to my eyeballs, which are not trustworthy, at 3, negative 4-ish. 1, 2, 3, 4. Okay, and we have the process down. 1, 2, 3, 4. We have the process down for getting those exact values. But just to give ourselves a rough sketch, we have a regular step pattern. So over 1, up 1, over 2, up 4. Bingo. Oh man, it's lumpy on this thing. You draw a better sketch. Okay, that very approximately is our first curve, y equals x squared subtract 6x plus 5. They've asked us to draw the second curve, which is in vertex form, on the same grid. So let's do this one in red. What do we know from unit number 1 about this particular form? Well, I know it's called vertex form. You'll never guess what it tells you. I know there is no number there in front of the bracket that's more interesting than invisible 1. So it is normal step pattern. And it opens upwards. And I know from the vertex form that my vertex is going to use this number and this number. Remember that things in brackets are backwards to how they might appear. This vertex would be 3 to the right, down 4. So let's use our graphing calculator and have a look at it. So I'm going to go to equation number 2 and write in the second equation, which is y equals bracket x subtract 3 squared subtract 4. So those would both be subtract signs as opposed to the negative down at the bottom. That can be a little annoying. Okay, and then we hit graph, and hopefully we'll be able to see it as well. There's the first one. Oh, I don't see the second one. So what can we conclude from the matter? It appears to be the very same graph, one on top of the other. Does that make sense to us? Well, it has a normal step pattern, same. It opens upwards, the same. And this one we know has vertex 3 down 4. So it appears to be the very same parabola. So we wanted to remind you, wow, that's bad. We wanted to remind you that parabolas can be written in different form. And the numbers are deceitful and look entirely different. And we can be fooled into thinking that parabolas are not the same. So we want to refresh you on vertex form today, how to graph them, and what they tell us. So first two chapters, just getting us into parabolas. Then chapter 3 that we just finished looked mostly going between factored form and standard form. Use slightly different letters than we have up on our anchor chart. So in factored form, the A will tell us the step pattern or the stretch factor or the vertical expansion, however you want to word that. That A value, if it is negative, tells you your parabola is upside down. If that A value is a fraction between 0 and 1, then our parabola is wider, fatter, vertical compression. You can say a lot of different things. And it affects our step pattern. So instead of the normal over 1 up 1, we would go over 1 up a fraction. So it's going to be a wider look to it. If A is greater than 1, or if A is less than negative 1, so negative 10 for instance, our parabola will be skinnier or stretched. It's a vertical stretch. The A value in all three forms does the very same thing. In factored form, our two values for R and S tell us our x-intercepts. We would write those as points. Sorry, I'm kind of trespassing all over the place here, but we have one x-intercept of whatever value R is, and the other one is S. Notice in the form that we have right now, I have x subtract R would give me a positive x-intercept of R. X subtract S gives me a positive S for an x-intercept. If I had, for instance, x plus 5 as one of my factors, then I would have an x-intercept of negative 5, always opposite to how it appears in a bracket. Standard form was the second one we spent time at, and it's not so helpful. That A value is still the same. It tells you the basic shape and direction of the parabola. But the only other helpful thing, unless you're a physicist, just saying, is this value right here, which is our y-intercept. That would be the initial starting value of that parabola. If you're talking about something like time and height, that initial value can be very helpful. Lastly, in vertex form, that's where we started this whole mess. We were practicing drawing these because it can be very helpful. That A value tells you the shape and direction, and the H and the K tell you your vertex. And your vertex is your highest or lowest point, which will give you a maximum and or minimum value. The vertex lies along the axis of symmetry, and it can tell you when you get to your highest or lowest value. So your vertex can be very helpful. We're going to write equations for these two parabolas, and we're going to do it as accurately as we can. Now, the one problem with your handout is that it didn't photocopy super clearly. So I'm going to ask you to trust me that this vertex is actually right on 5, negative 3. It's just really hard to see it on yours. Okay, for the first one, if you trust me, we're going to write the equation of each parabola in vertex form. So I know it looks like this, where H and K are my vertex values. So the vertex for this thing is 5 and negative 3. So what I know so far is that my equation is going to look like this. And be careful, if you have a vertex that's 5 to the right, you do write it as negative 5 in your bracket. What I want to know now is that A value, the shape. It opens upwards, so I know A should be positive. But instead of guessing, I am going to substitute a value. Going to substitute the value 2, 6, because it's the only one that they gave me for sure. And I am going to put the 2 wherever I see an x value. And I'm going to put the 6 wherever I see a y value. Because it's a point, that is an x and y coordinate. Or those are x and y coordinates. So 6 goes here. I'm solving for a. I put a 2 where this x is. And then I am going to solve. So order of operations would say, hey lady, can you do the bracket first? So I have, and I'm going to write a lot of lines for this. Sometimes we can shorten our process a little bit. But 2 subtract 5 is negative 3. I'm going to square that. Negative 3 squared is 9. Now that I've done all the work that I can do, I'm trying to solve for A. And when we're trying to solve for something, it's like peeling away the outermost layers first, kind of like dealing with an onion. So I'm going to get rid of the furthest bits. I'm going to get rid of him first. So to get rid of subtract 3, I'm going to add 3 to both sides. Sometimes it's helpful to remind yourself what you just did. So if I add 3 to both sides, I have 9 equals A times 9. To get A by itself, I want to get rid of that multiply by 9 business. So I'm going to divide both sides by 9. A equals 1. So final answer, y equals 1. X subtract 5 squared negative 3. Okay, second parabola. Again, I'm asking you to trust me because yours isn't so very clear. But we do have a vertex that's exactly at negative 4, 6. And I'm asking you to write the equation of this parabola in vertex form. You know that it is upside down, so that you know your A value is going to be a negative number. But we're not going to guess at it. We're going to put in values that we know. So if we know the vertex is negative 4, 6, I can put those two numbers in for h and k, x. If I want to have a vertex that's to the left 4, I'm going to do x plus 4 squared. And then the vertical shift is always, as you would think, plus 6. Secondly, I want to find that A value, so I'm going to substitute a point that I know, and the only one I'm sure about is negative 2, 4. So I'm going to substitute the negative 2 for x and the 4 for y. And I'm not trying to be sarcastic at all, but a point is xy. So that's where you put things, the x for the x value, the y for the y value. And so I'm going to write 4 equals A. I'm going to put that negative 2 where I see x, add 4 squared, and then a plus 6. So now I'm going to do what I can do to tidy it up, so to speak, and then we'll solve for A. So first thing I need to do is do my bracket. So negative 2 plus 4 is 2. And I'll just rewrite all this. Here we go. Then I can square the 2. A times 4 plus 6 equals 4. Okay, now I set about solving this thing. I want to get A by itself. So I'm going to undo all of the outer layers first. So I'm going to subtract 6 from both sides. I have negative 2 equals A times 4. To get A by itself, I want to get rid of multiply by 4. So I'm going to divide both sides by 4. Final answer, A equals, because those 4's disappear, A equals negative 2 over 4, or negative a half or negative 0.5 if you have to. Okay, time to practice.